Kirchoff's laws 1. Part A. Find the potential of point A with respect to point B in the figure. So potential of A with respect to B. And part B. If points A and B are connected by a wire with negligible resistance, find the current in the 12-volt battery. Okay, so in part A, we have no connection between A and B. And if I complete this loop here, write Kirchoff's voltage law, then I'm assuming that the current is flowing in this direction. So you can see current flows from positive to negative potential, plus minus, plus minus, plus minus, plus minus, plus minus, and completes. So let's start writing the potential drops at each point. So if I start at point C, first I will encounter a minus 12 volts. So Kirchoff voltage law, KVL, for loop 1, KVL1, going from point C back to point C. First I encounter minus 12 volts. Then I have a 1 ohm resistor, so I see the positive potential. I multiplied by 1 is I plus I. Then I see the same current I flows through the 2 ohm resistor, so it's going to be, again I encounter the plus, so it's 2I. I plus 2I. The same story for this resistor. Once again, I encounter a positive here, so another 2I. Now I see this resistor. The resistance here is 1 ohm, so I see another plus I. Plus I. Then I see this resistor, 2 ohms. Well, before I see that, I see this 8 volt potential source. So there's a plus 8 here. So plus 8. Then I have plus 2I and plus I back to point C. This should add up to 0. The voltage difference, voltage of C with respect to Z has to be, C with respect to C has to be 0. So once again, minus 12 plus I plus 2I plus 2I plus I plus 8 plus 2I plus I. So if I add these values, I'm going to get I, 2I, 3I, plus 2, 5I, 6I, 8I, and 9I. So this will give me 9I. And then I have minus 12 plus 8 minus 4 is equal to 0. I will find that the current is 4 divided by 9 amps. So the current that flows through the circuit is 0.44 amps. So Kirchoff voltage law helped me to find this current. Now what I want to know is the potential of A with respect to point B. So I'm going to look at this loop now. I'm going to call this KVL2. So I know that this current I flows through these portions of these resistors, but not through these resistors. Okay, so let's write KVL2, Kirchoff voltage law 2. So let's start at point A. So I'm going to encounter potential of point A with respect to point B. So VAB. Then there is no current flowing through this resistor. There is a 10 volt voltage source here, so I will encounter plus 10 volts. Plus 10. Then I have no current flowing through this, so there's no voltage drop here. There is a voltage drop here, plus I, then I encounter the minus electrode here, so minus 12 volts, then I have this 1 ohm and 2 ohm through which the same current I flows again, so I have plus I and plus 2I. Now I'm back to point A. This should be equal to 0. So from this I obtain potential of A with respect to B is 3I plus I is 4I, 4I minus 2 here. If I take it to the right hand side, it is 2 minus 4I for potential of A with respect to B. So that's going to be equal to 2 minus 4. The current was 4 over 9 amps. So it's going to be 2 minus 16 over 9, which means the potential of A with respect to B is 0.22 volts. Okay, that's using this second loop and noting that there is no current flowing through these two resistors, but there is a potential drop or potential increase due to the source depending on the direction I'm following. Now in part B of this problem, there is a wire that connects A and B. Now what I want to know is the current in the 12 volt battery. Where is the 12 volt battery? It's the top one. Okay. Now I can have three different currents flowing through these three different branches, I1, I2, and I3. So I can use Kirchoff current law, and basically I see that for this point here, I3 is going out, I2 is going out, I1 is going out. So using the Kirchoff current law for this junction where they meet, I can write Kirchoff current law as I1 plus I2 plus I3 is equal to 0. Now I'm going to follow this loop again, this time noting that there are two different currents flowing through these different branches. It's going to be KVL3, and I'm going to start at this point and end at this point, at the junction point. So I will go like this. So I1 is flowing, assumed to flow in this direction. So there is a voltage drop here, plus minus here. There is a minus 12 volts, plus minus 1 ohm. So it's going to be 1 times I1, plus minus here again. So there's a minus here. And then when I go to this branch, because I2 is assumed to flow in this direction, there is a minus I2 and plus 10 volts. And once again, I'm going to have a minus 3I2, so because this is 3 ohms. Okay, so let's write the KVL equation, Kirchoff voltage law, for the third loop I'm encountering here. I start here, so I have I1 times 1 ohms. Then I go to here, minus 12 volts, because this is the negative terminal. So minus 12. Then I have another I1, because I'm on the same branch here, plus 1 ohms, and plus 2 ohms, so 2I1. Plus 2I1. Then I go to this branch, and now I encounter minus I2 times 1, so it is minus I2. Then I encounter this voltage source, plus 10 volts. So I have the plus 10 volts. Then I have the 3 ohm resistor here, but the current is flowing in this direction. So plus minus, if I come from this side, it's going to be minus 3I2. Minus 3I2 is equal to 0. That's KVL 3. So if I look at I1 values here, 2I1 plus 2I1, I have 4I1. So this is 4I1. And I2 values, minus I2 minus 3I2 minus 4I2. This must be equal to minus 12 plus 10 is minus 2. On the right hand side, this becomes plus 2. So this gives me an equation between I1 and I2. I1 minus I2 is equal to 0.5 amps. Okay. Now if I consider this loop, the fourth loop, KVL3, this time I'm going to start at this point and let's start at this point. So I will basically continue like this. So let's see here, the current is flowing in this direction. So this is plus minus, this is plus minus. Basically, I'm assuming the current is flowing in this direction. So I will have 2I3. So if I start at this point, I will have 2I3 first. So now I'm writing Kirchoff voltage law, fourth one, 2I3, because I see the plus terminal here. Then I have minus 8 volts, 2I3 minus 8. Then I see the plus 1I3 here. Here I'm going through this plus minus. So plus I3 for this branch. And finally I have the plus 2I3 as the potential drop. 2I3. Now I go to this branch. Now I have minus I2 plus 10 and minus 3I2. So minus I2 plus 10 minus 3I2. This must be equal to 0. So what does this equation tell me? 2 plus 2 plus 1, 5I3, 5I3, 3I2, 1I2, 4I2 minus 4I2 must be equal to minus 8 plus 10 plus 2 to the right hand side, it's minus 2, minus 2. So I have this equation here, which says 5 times I1 plus 5 times I2 plus 5 times I3 is equal to 0. Then I have this equation from KVL4 equation, 5I3 minus 4I2. So I write 5I3 minus 4I2 is equal to minus 2. If I subtract these two equations, then I will have 5I1 minus minus, this will become plus, plus 9I2. 5I3s will cancel, will be equal to minus minus, this will become 2. And at the same time, I have KVL3 equation, which is I1 minus I2 is equal to 0.5 amps, or in other words, 5I1 minus 5I2 is equal to 2.5 amps. So if I subtract this second equation from the first equation, what am I going to get? 9I2 minus minus plus, it's going to be 14I2, 9 plus 5, 14I2 is equal to 2 minus 2.5 minus 0.5. So I will find that I2 is minus 0.5 divided by 14 amps. But what I'm after is I1. So I1 is equal to I2 plus 0.5 amps. That's the KVL3 equation. So this becomes 0.5 minus 0.5 divided by 14, which means I1 is actually 0.5 times 14 is 7 minus 0.5, 6.5. 6.5 divided by 14 amps, which is I1 is equal to 0.464 amps. So this is the answer I finally reach using these two Kirchoff voltage laws and Kirchoff current law. So 3 unknowns and 3 equations. I can solve them and find the current going through the first branch. Okay, so this is an application of Kirchoff's laws. First, we want to find the potential of point A with respect to point B without any connection between the two. So I have written Kirchoff voltage law for this first loop here. Starting at point C, ending at point C, I have minus 12 plus I plus 2I plus 2I plus I plus 8. Then I have plus 2I and plus I, it's adding up to 0. That gives me the current, 0.44 amps. Once I know the current, then I can use this loop, noting that there is no current on this branch. Only voltage drops will occur on this the voltage source, 10 volt voltage source. So now I have, starting here, voltage of A with respect to B, VAB, no voltage drop here, plus 10, no voltage drop here, plus I, minus 12, plus I, and plus 2I. So that gives me the voltage drop, the voltage of A with respect to B, that is 0.22 volts. Now for the scenario where I have a connection between A and B, Kirchoff current law tells me that if I assume this direction for these currents, I1 plus I2 plus I3 is equal to 0. Writing Kirchoff voltage law for this loop, now I1 is the current that flows through this branch, so I will start with I1 minus 12 plus I1 plus 2I1. So I1 minus 12 plus I1 plus 2I1. Then I will have here, there is no voltage drop here because it's connected, negligible resistance. Then I have minus I2 plus 10 and minus 3I2. So that adds up to 0. That gives me the second equation, I1 minus I2 equals to 0.5 amps. And for this loop here, I have the two branches having currents I2 and I3. Now, starting at this point, I have 2I3, then I have minus 8 volts, then I have plus I3, plus 2I3, minus I2, plus 8, and minus 3I2. So at each point for the resistor, I note that whichever direction I'm assuming for the current, the current flows from high potential to low potential. So these are plus and minus. So that gives me another equation, 5I3 minus 4I2 is equal to minus 2. Simultaneously solving these three equations, I can find all of the currents. For example, I find that I2 is negative, so it's actually not flowing in this direction, but it should be flowing in this direction. And I find that I1, using the known value of I2 from these two equations, substituted into KVL3 equation, I1, the current that flows through the 12 volt battery, should be 0.464 amps.